Hi, this is King of Review. Here we have to solve two equations, one with a log and one with some exponents. Let's start with the first equation. Log base 2 of x times y is equal to 1. I'd like to solve this equation for x and y. I'd like to get x and y out from inside the log, basically. And to do that, we can rewrite the log in exponential form, using the property of logs that says if we have the log base b of some number a equals some number c, that's the same thing as writing b to the c power equals a. Applying that to our equation, we get 2 to the first power equals x times y. Rewriting this equation, 2 to the first power is just 2. So now I've got one equation that's just in terms of x times y, rather than having a log in it. Let's see if we can do something with the second equation as well. Here, x and y are in exponents rather than a log, so we need a property of exponents. And there's a nice property of exponents that says if we have some base b to the a power times some base b to the c power, that's the same thing as that base to the a plus c power. If we use that property in our equation, we can get 2 to the power x plus y is equal to 8. Now I'd still like to get this problem as x plus y by itself rather than x plus y in an exponent. So we'll use one more property of logs that says if we have the log base b of b to some power x, the log and the b cancel each other out and we're just left with x. So with that in mind, I'd like to take the log base 2 of both sides of our equation, since we have 2 to the power x plus y. The log base 2 of 2 to the x plus y cancels out and we just get x plus y. The log base 2 of 8, we can use this property over here on the left side. If the log base 2 of 8 is equal to some number z, that's really the same thing as asking 2 to what power z is equal to 8. Well, I know that 2 to the third is equal to 8, so that means this log has to be equal to 3. Now we have two equations to solve for x and y, and I think the easiest thing to do would be substitution, because this equation here can very easily be solved for y by merely subtracting x on both sides. So we get y equals 3 minus x. Let's substitute that in for y in our other equation. So we have x times y is equal to 2, but now I know y is equal to 3 minus x. If we distribute the x, we get 3x minus x squared equals 2. I'd like x squared to be positive, so I'm going to move every term on the left side over to the right side, which will give me 0 equals x squared minus 3x plus 2. And now I'd like to factor this side, since it's equal to 0. And I believe it does factor. It'll be x minus 1 and x minus 2, because negative 1 times negative 2 equals positive 2, but negative 1 plus negative 2 equals negative 3. This tells me that either x minus 1 equals 0 or x minus 2 equals 0, which means x is equal to 1 or x is equal to 2. Well, we have two possible answers, and let's see what we would get for y in each of these two possible answers. We know that y is 3 minus x. Well, if x is 1, y equals 3 minus 1, which is 2, or we have y equals 3 minus 2, which gives me 1. So no matter what, my solutions are 1 and 2. Now I know that I want x to be the bigger of the two numbers, so if my solutions are 1 and 2, x is going to be the 2, and y is going to be the 1. We need x to be bigger than y, meaning this first solution doesn't work. So 2 and 1 are the solutions for x and y, and if I want x minus y, that's going to be 2 minus 1, or just 1. And there is our final answer. Thanks for watching.